Physics vibes, let we go. So to understand that question, you need to understand a couple basics here. So you see this dashed line over here is a normal. You see this solid line, that's called the boundary line. The boundary line separates two mediums. So over here could be air and over here could be glass. And the normal always exists perpendicular to the boundary line. Now a couple things I want you all to understand. If you're going from a more dense to a less dense medium, the refracted ray is going to bend away from the normal. If you're going from a less dense to a more dense, the refracted ray is going to bend towards the normal. So let me explain what's going to happen here. So let's just say we have an incident ray. So the incident ray is the incoming ray. So, and the angle of incidence is always measured with respect to the normal. Please remember that. So this is the angular incidence. So I'm going from glass to air. Since I'm going from a more dense to a less dense, I'm going to bend away from the normal. So I'm going to bend away from the normal. Right? Gonna bend away from the normal. And this angle over here is going to be theta r. Now, since we're going from a more dense to a less dense, again, we're bending away from the normal. So there's going to reach a point, watch, there's going to reach a point, right? If I keep on increasing the angular incidence, there's going to reach a point where this is going to end up exactly on the boundary line. I'm not sure if you all could visualize that. But if I keep, if you keep increasing this angle is going to bend further away from the normal. So eventually, you're going to reach an angle of incidence, and we call the angle of incidence critical angle. And at the critical angle, the angular refraction is going to be 90 degrees. So that is what happens at the critical angle. So at the critical angle, right? So at the critical angle, the angular incidence is C, and the angular refraction is 90 degrees. So keep that in mind. I hope we kind of understand that. Now, what happens when you cross the critical angle? Let me show you. So you can imagine if you increase theta I past the critical angle, well, it's going to bend even further away from the normal. But remember, it's already on the boundary line, so it's going to dip into glass to glass. And anytime it dip into the same medium, total internal reflection will happen. And in that situation, the angle of incidence here would be equal to the angle of reflection. You call it the angular reflection now. So I hope we understand that. So in this diagram, they're saying that the critical angle of glass is 42 degrees. So Akil, what does that mean? The first thing we should do is we should probably establish what is the boundary line and where is the normal. Okay? So over here we have air and over here we have glass. This over here would separate the air and the glass. So that's the boundary line. And this over here, this dashed line, is the normal. Now they are telling me that the critical angle of glass is 42 degrees. So you see how this angle here, this ray here is coming in, that will be the incident ray. This is theta I. Now let me show you what would happen at the critical angle. So at the critical angle, this would actually happen. So you see this? This is at 42 degrees. And let me try to explain it now where you can understand. So remember, at the critical angle, what is happening? At the critical angle, the angle of refraction is 90 degrees to the normal. So in this scenario, this represents the critical angle. I feel like you don't understand that, so I'll explain it again. So if 42 degrees is the critical angle, then at that point in time, the angular refraction is going to be 90 degrees to the normal. And well, you would have saw it over here, right? You would have saw it over here. So at the critical angle C, the angular refraction is 90 degrees to the normal. So this diagram over here actually represents the critical angle. 42 degrees will be over here. Now, if I were to increase the angle of incidence past 42 degrees, it's going to dip into glass to glass, and total internal reflection is going to happen. So I think you could see that. Because 48 is more than 42, it's going to now move further away from the normal, and it's going to end up going from glass to glass. And at that point, you have total internal reflection. So at that point, theta I will be equal to theta r. I hope you understand that.